Okay, good afternoon, class. Welcome again now. Welcome to a brand new week. Okay. This week we are going to have 2 lessons also for this week now. Next week only we have 1 lesson. Okay. Next week is Hari Raya week, so we have 1 lesson only now. But this week are still 2 lessons. Okay, remember Okay. Our last lesson is lesson 3, right? Do you remember, guys? Lesson 3. Lesson 3 is on specific latent heat, right? After we already discussed the whole lesson 3, and then I think we are halfway answering the question, correct not? Okay. I would like to normal. I want to ask a few questions first to warm you up first. Okay. Okay. Latent heat. Specific latent heat, right? Okay, my question 1. Question 1, listen carefully. How many types of latent heat you have learned? How many types? Can one you? How many types of latent heat you have learned? Can one you? Please answer. Don't hide yourself. Can one you? I know some of you are going to hide yourself. Don't want to answer me one. Was you may? How many types of latent heat you have learned? How many types of latent heat?
Latent heat of fusion and vaporization.
Yes, very good, Posumate. Latent heat of fusion and latent heat of vaporization. There are 2 types, isn't it? Right? Okay, next question. What is fusion? Latent heat of fusion means what? Marvin, what is latent heat of fusion? Marvin? Marvin, can you answer? What is latent heat of fusion?
Solid to liquid.
Yes, correct. Very good. It's a heat required to change 1 kilogram of solid to liquid. Very important, must say, without change in temperature. Okay, another question. What is latent heat of vaporization? What is that? Yi Hui, please answer. Don't always hide yourself. What is latent heat of vaporization? If fusion is changing from solid to liquid, then what about latent heat vaporization? Mei Hui? Mei Hui not there. Okay. Mandy Tay. Mandy, Mandy, are you there? All these people know around one. Kong Fan Xin? Kong, what is latent heat of vaporization? Kong Fan Xin? I don't know whether they cannot hear me or they don't want to answer.
Teacher. What teacher?
What is latent heat of vaporization?
Is the quantity heat of energy required to change 1 kilogram of a substance from the liquid state to the gaseous state without a change in temperature.
Yes, very good answer. Thank you very much. Okay. All right. And last question. What is a formula for latent heat? I think you only learn 1 or 2 formula only, right? What is a formula for latent heat? Formula is what? What formula you learn in latent heat? Chin Yi Hong. What you learn in latent heat? What formula you have learned? Chin Yi Hong. What formula you have learned? Kevin Lim, what you have learned now? What formula?
Q equal ml.
Yes, very simple. Q equal to ml. That's it, right? Q equal to ml. And one more same formula is PT equal to ml, correct? Not PT. When the heat energy Q was supplied by electric heater, right? So the formula become PT equal to ml lah. Okay, okay. Now I suppose last lesson we stopped at question. I want to finish up the whole set of questions tonight. Let me see first. Where is it now? Okay, I think it's question 16 or something like that. Correct not? One first. I must click share screen. Okay, I didn't click just now. Sorry. Okay, now. Question 19. I think somewhere here. Correct not? Okay. Question 19 we finished. Now it's question 20. 20 is structure question. Okay, come. We do slowly lah. No need to be so rushed lah. Do slowly. Okay. Okay, read the question. Figure shows figure shows an arrangement of apparatus to determine the specific latency of fusion. So, okay, this setting is different from what we have discussed last week. Actually, it's slightly different, isn't it? Right? Okay, now a beaker contains 0.24 kilogram of ice. So inside here got ice, 0.24 kilogram. The time, okay, here the time, the word time cannot see. The time, okay, let me take out the pen first. Go slowly lah. I want to take out the pen slowly. Then you see someone coming. Sima now want to come. Another one coming. Sim Pun Keng. Okay. At the word time, the time taken to melt the ice. Okay. In this question, to get the final result, right, you have to wait until all the ice melted, All the ice must be melted, and then only you can find the answer one. Okay, right? Okay, now it's 0.24 kilogram of ice. Now the question, what is the function of beaker P? Now there are two beakers, One beaker is inside containing the ice. So this is a thermometer, this is a heater, right? Heater used to, you on the power supply, right? The heater will heat up the ice and then make the ice melt, okay? Then outside there is another beaker here outside. Then what is the purpose of this outside beaker? They ask you, why need to have another beaker outside? Okay, you see the answer? Okay, the answer is to prevent, actually to prevent heat from the surrounding from coming in, Surrounding heat to come in, okay? To prevent heat enter from the surrounding, okay? Actually now, the issue here is what, the ice is melt. We want the ice melted by the heater only. So we don't want the heat from the surrounding to come in, Okay, that's why use another beaker to block it. Okay, so to prevent surrounding heat from coming in and then cause the ice to melt, this will cause the result not accurate. Understand? So the answer is prevent heat enter from the surrounding now. Okay, this beaker capture a layer of A, okay? you know A is not good conductor, right? So this layer of A will stop the surrounding heat from coming in now. Huh? Okay, the rheostat is here. Rheostat, I'm sure you know huh? To control the current now. Rheostat, you can adjust to make the current big or current small. Okay. Okay, so I think okay. Next one. You read the question first. Next part. My mouse are not so sensitive. I don't know why. What happened? The mouse not so good. Okay. Next, in this experiment, the reading of wattmeter, ammeter, okay, got two, wattmeter, ammeter. Wattmeter is 12 volt, ammeter 4 ampere. All the ice melted in 30 minutes, okay? We wait until 30 minutes, all the ice melted, Now the question, determine the specific latent heat of fusion of ice. Okay, now no power given, the heater power not given, but you are given wattage and current. So how to find the heat energy? Okay, you learn something new. You see here. Actually, this formula you need to, just a matter of time, you need to learn. Power is wattage multiplied current. P equal to VI. So original formula is PT equal to ML, right? PT equal to ML. So now P substitute a VIT, so become VIT lah. Because power is VI. This is the third formula you learn, First one, the original formula is Q equal to PML, right? Q equal to ML. This one is the second one, PT equal to ML. Third, VIT equal to ML. This is the third formula lah. When you are not given power, but given wattage and current, so use VIT to find the heat energy, okay? Wattage is 12, current is 4. Time, 30 minutes change to second. Mass, 0.24. Then you find the L now. So you get 36000. Okay, so these are answer now. Right? Okay, so can understand now? The next question. Okay, copy already? Okay, next part. Next part of the question, okay? Now it's over here. Now another set of experiment. Just now the set different, now another set. This was the set we have discussed in the experiment, right? Figure B show another arrangement of apparatus to determine the latent heat of fusion. Use another set of experiment, okay? Now, use a filter funnel. We put ice here, put the heater heat up the ice melted, so we collect the water from here. Understand? Okay, Now the question, state one advantage use the arrangement apparatus in figure B. Okay, the question already said this set of experiment is better, because it asks you to state one advantage. One advantage means definitely this set is better. Okay, can anyone tell me what advantage compared to the previous diagram? This experiment, this diagram, can you tell me one advantage? Compared to the previous experiment, this one got one advantage, very obvious one. What is the advantage? Justin, are you still there, Justin?
Yes.
Justin Yip? Justin,
yes,
can you try or not? Can you try tell me this set of experiment has what advantage? Yes. Think they might try slowly, just try lah. Got one advantage compared to the previous experiment. What advantage is that? Okay.
The heater.
Yes.
Is the heater about the heater or the cupboard?
No. Heater same last experiment also. Okay, I'll give you some tips. You all, everyone listen now.
Okay.
Your previous experiment, right? You need to wait until all the ice melted, Okay, all the ice melted by the heater, then only you can get the result. That's why the question just now say 30 minutes, 30 minutes time taken to melt all the ice, right? Okay, now in this experiment, so what is the advantage? Anyone can try? Anyone want to try or not? Just try lah. Huh? Anyone want to try? Give answer. Kevin, you want to try or not?
Need shorter period of time to obtain results.
Yes, again, come again.
Need shorter period of time to obtain results.
Yes, correct. Very good. This one, this experiment, right? We don't need to wait until all the ice melted one. No need. The time is we fix ourselves. You want to heat it up for 10 minutes. Go ahead, just 10 minutes enough already. Understand? So the advantage of this experiment, it can save time. Okay? So the answer is, copy down the answer. Save time. It does not require all the ice melted. No need. We don't need to wait until all the ice melted. No need one. This experiment, no need. Okay? So you just set a particular time. That's it. How much water collected? That's it. So use formula to calculate. Understand? So the advantage of using this experiment is it can save time. Okay? Because don't require all the ice to melt. Okay? Okay, next question. Now this question very long. Read first, okay? When the arrangement of apparatus in figure B, these are the observations show that the values of specific latent heat of fusion is larger than the standard value. This one many times I repeated already. The answer you get sure is larger than the standard value one. Okay, explain why and suggest a method to improve. Okay, why the answer is larger than the standard values? Why? What is the reason? Why the answer always is larger? Explain why it happened and then suggest a method to improve it. Okay, the answer is because of heat loss, correct? Not when heat loss already, you see the experiment, you do like this, right? Heat can loss, heat from heater can loss, right? Once the heat from the heater lost already, right? So the mass of the ice melted now become less already. And you see here, I explain here. Formula is Pt equal to ml, right? You want to find the latent heat L, so bring the m over to dy. Okay, now because heat lost to the surrounding, right? The heater heat run away, so the ice melt become less already. So the mass of the ice melted become less. So this one becomes small. So when you divide by a small number, your answer become big log. So your latent heat always larger. Understand? That is the reason. Okay, so the answer is you can copy. Now the whole answer here. Heat loss to the surrounding, right? The problem is heat loss to the surrounding. So the mass of the ice M melted is less than the expected value, right? From this formula, smaller mass M, bigger value L, okay? Right? That is the reason why the L, the latent heat, always larger. Okay, to overcome this problem, right? So fully cover the heater with the ice. We don't want the heat loss, right? Just now we see the diagram or not. The heater actually are not fully covered by the ice. So you want to reduce the heat loss, so you fully cover the heater with ice, or wrap the filter funnel with cloth or tissue paper to prevent heat loss. Okay? All right, copy down the answer. เห็นนะ Okay, finish. Okay, come. Question 21 now. Okay, next question 21. Yeah, this question. Okay, read the question. A solid substance mass 0.1 kilogram heated using 200. Okay, the heater is 200 watt. 200 watt. The graph show the variation. Okay, we see our temperature here go up, then the temperature stay constant, then later on the temperature go up. Okay, you all must understand now. From here to here, actually, what happened here? When you heat up, right? So you can see here the temperature go up, correct? Not the temperature go up, right? Something to the mouse. Okay, so here temperature go up means is in solid state, solid. Then after that started to melt. Once started to melt, the temperature stay constant. Do you remember or not? During melting process, when it melt, right? Melting process involving latent of fusion. So latent of fusion doesn't involve change in temperature one, So at this region, temperature say constant means this is melting, melt. Okay. So after that, everything finished melted already, then become liquid. You continue to heat up, so the temperature go up. So the answer, okay, Wx here is solid. Here becomes solid and liquid, a bit solid and a bit liquid lah. And last all become liquid. Is okay lah, right? You understand? Okay, the next, using kinetic theory of matter, explain why xy temperature remain constant. Here, I do want to show you answer first. Can anyone tell me why? During many times already, I explained why during this process of melting here, the temperature never change. That's why now that exactly they ask you to explain why the temperature remain constant. Why? Why temperature remain constant? Why? Okay, Justin, I know I heard you want to say something. Justin, can you explain why temperature never go up?
Heat is absorbed to overcome the force of attraction.
Yes, correct. Okay. At that time, the heat supply is absorbed to overcome the attraction force, or we call it intermolecular binding force, isn't it? Okay. So meaning that the heat does not increase the kinetic energy of the molecule. When kinetic energy of molecule never change, means temperature never change. Okay, so the answer, okay, copy. The heat absorbed used to break the intermolecular binding force, or we say to break the attraction force within the molecule also can. Okay, so the average kinetic energy of molecule remain constant. Okay, you must say here, no. When the energy used to break the binding force, right, meaning that it would increase the kinetic energy of the molecule. So when the kinetic energy of molecule does not increase, means the temperature will not change. Okay, you must remember this concept. Temperature change means it will have change in kinetic energy. When kinetic energy become higher, temperature become higher. When kinetic energy become less, temperature drop. When kinetic energy never change, means temperature never change. So remember that. Okay, got it or not? Okay, next one. YZ, the temperature increase. YZ, the temperature increase. Why? Just now, they ask you to explain XY temperature remain constant. Okay, we explained already. Now they ask you to explain why at YZ the temperature increases. Why then? Okay. I want somebody else to answer now. Justin, you don't answer. I know you know the answer one. Huh? Justin, I want to give someone to answer. Okay. Lim Sing Yin. Okay. Lim Sing Yin. Are you there now, Lim Sing Yin?
Yes.
Lim, can you answer? Why at WZ, here the temperature go up there? Here just now we heard the answer already. Here temperature never go up. But why here the temperature go up? What is the reason? Lim?
Kinetic
Just try.
Kinetic energy increases.
Yes, correct. Yeah, that is the answer. That's it. Okay, and now you see the answer. Heat absorbed increases the average kinetic energy of the molecule. That's it. Okay, because the heat supply continues, so now the molecule absorbs the heat, right? So the heat absorbed increases the average kinetic energy of the molecule. Okay, because now in the forms of liquid already. So now any heat you supply now is increasing the kinetic energy. Okay. Copy the answer now. Okay, now C. Okay, next question calculation Find the melting point. Melting point, can someone tell me what is a melting point? Look at the graph. What is a melting point? Okay, let's call what these people no answer one, no sound one. Mignish. Okay, Mignish, are you there? Mignish,
Yes, sir. Yes,
Mignish,
sir.
can you look at the graph? Can you tell me what is a melting point? You see the graph? What is the melting point? What is the temperature?
0 degrees Celsius.
Yes, correct. 0 degrees Celsius. 0. Okay. 0 degrees Celsius. Okay. And next part is calculate the specific latent heat of fusion. Okay. This one I show you the answer straight now. Okay. So to find latent heat, right, you must use a part I told you before, right? You must only choose the part without change in the temperature. Okay, only this part only. You must use only this part. No change in temperature means only here. Okay, only this part. Okay. Then the mouse, I think battery, no battery. My mouse very hard to control. Okay, doesn't matter. I don't want to change battery now. Okay, so it's here. You must choose this part only. The time taken is here to here. Okay. Okay, now calculation. ET equal to ml. Power given in the question 200 watt, right? Time 7. Excuse me, 9 minus 2, so you get 7 minutes lah. Change to second. Okay, mass 0.1. Mass, where you get the mass 0.1? 0.1 given in the question 0.1, right? It's here 0.1. Okay, given in the question. Okay. Okay. PT time 7 minutes, 9 minus 2. You see the graph. Only take the horizontal part. ml, so L 840,000 joule per kilogram. Okay, for latent heat, the unit is joule per kilogram. No degree Celsius one, joule per kilogram only. Okay. Then, okay, come, let's move on now. Next, move to. No, I think finish already. We have finished, right? Okay, that's good. Okay, we have finished. Okay. Anyone want to ask any question here or not? Anyone want to ask any question? Okay, you can ask now. If you want to talk now, mind, okay, you can use your chat. You can type here any question you want to ask for lesson 3. We have finished already, right? The paper, correct? What? Let me check the paper. Any question or not? No question. Very good. Everyone, no question to ask. Yong Jia Sin, any question or not? Hold on. Ong Jia Sin, any question? Ong Jia Sin?
No, no.
No question.
Yes.
Very good. No question. Jin Yi Hong, no more there. Lau Guan Xuan, any question? You Tong, any question?
No, sir.
No, sir. Okay. Chua Michelle, any question?
No, sir.
No, sir. And then the only answer they give is no, sir. No, sir. Yes, sir. No, sir. Chu Hong Xuan, any question or not? Chu, are you there now? Chu Hong Xuan?
No, sir.
No, sir. Okay. Now mine all. Okay. If no now, okay, class I share in the group one set of paper 3 questions. These are not the chapter 3 question, I know you all face a lot of problem in chapter 3 one. Okay. Chapter 3 because maybe you did not study properly the chapter 3 gravitational. You all have the paper with you now or not? Juling, do you have the paper with you? This paper, come, let me show you the paper now. It's very thick. This set of paper, okay? This chapter 3, I will go slowly now. Gravitational, okay? Chapter 3. You have the paper or not? No paper, you just see the question here. Take a piece of paper, copy down the answer, can or not? Okay, we go slowly lah, one by one, okay? Shall we start now? Chapter 3 now. Okay? Right, question 1. Read the question. See, got the answer already, right? Why the answer is D there? Why? The mass released just above the surface of planet. Okay? Mass is m and the radius is r. Which of the following expression give the initial gravitational acceleration? Okay, you must remember, Gravitational acceleration formula is G equal big G mass. This big G is a constant of gravitational constant. Understand? Gm over r squared. Okay, now mine. Let me take out the previous notes. I show it to you. Okay, come, give me some time. You have the note with you one. Okay, now mine I take out again. I show part by part for you lah. Consider like we do some revision here. My computer got a lot of things. I have to take a long time to go and find. 3. Not this one. Okay, who on? Find that, sorry, I cannot find the notes. Okay, who on first lah? Okay, let me find first. Okay. Okay, never mind, I cannot find the sorry. Okay. Okay, never mind. Why my mouse are very difficult to control. Okay, come. Let's move on now. See, I click, you don't want to close. Okay. You remember the formula, gravitational G equal to Gm over R square. Okay, the formula. Gm over, yeah. This one is to find gravitational acceleration formula, Gm over R square. Okay, second question. What is the shape of the path planet around the sun? Is ellipse shape, isn't it? Okay, not a perfect circle, it's ellipse, okay, ellipse like the egg shape, right? Ellipse. Okay, number 3. Okay, question number 3 now. What would be the duration of the year if the distance between the Earth and the sun is double? Okay, we know that duration for the Earth is 365 days, right? Okay, so 1 year our Earth go around the sun 1 round, 365 days. Okay, now if the question asks you, what is the duration for the year if the distance between the Earth and the sun is double? If the distance between the sun and the Earth now become double. Okay, we are using Kepler, third law of Kepler, this formula now. Okay, T square, the period time, T square over R square. R is the radius, is a distance, okay? Cube. Okay, T square over R cube equal T square over R cube. Okay, this is first situation. That's why I put here 1, 1. This is second situation, 2, 2. Okay, why got 1 and 2? Because we said the distance double, another situation already, so got 2. So this formula is using Kepler's third law. Okay, T square over R cube. T square over R cube. So you put here 1, then put here 2. Okay. Now, initially, the Earth surrounding the sun, the period is 365 days. Okay. So square. Radius, our Earth, the distance, let it as R1R. Not given value, doesn't matter, but we put it R. Okay. Now, what is the period when the Earth, the distance become double? Double means you put here 2R. 2R cube. Okay, 2R cube, R cube, r cube can cancel, right? So 2 power 3 become 8. Okay, so you use a calculator now, solve this equation here. I don't have space to write here, so you solve it now. So you get 1032 days. Can So what you do is like this now, okay? Here cube become 2 cube is 8. 8 r cube. So the r cube can cancel off, right? So here is 8. 8 multiply here, right? Then bring the square over here, becomes square root. So you get 1032. Okay? So meaning that now, if the Earth and the Sun distance is double, right? So 1 year become 1032 days, become very long already. Okay? Yeah? All right, now question number 4. This one very difficult question. Okay? Escape velocity. Class, guys, you know what is escape velocity? You still remember escape velocity or not? What is escape velocity? You tong what is escape velocity? You tong? You tong. You tong, what is escape velocity? Okay, escape velocity means is a minimum velocity needed for an object to escape from the Earth. You see now, when you want to go to outer space, right, you must escape from the gravity from the Earth, So you want to escape from the Earth gravity, right? You must have certain speed. The speed must be very, very fast. So that particular speed that we call escape velocity, okay? Escape velocity for the surface of Earth with this value. You must have this speed, then only you can escape from the gravity. What is the escape velocity from the point at the height 0.2 r further up, from the Earth's surface? Okay, escape velocity formula is here now. Take your time to understand it now. This one is the formula to find escape velocity formula. V equal to square root 2gm over r. Okay, the g nothing much. G is just a constant value. It's given one constant value, but it's not stated here. Okay, right? Mass and then r is a distance. Okay, now we are using two conditions, okay? By using this formula, right? Okay, the first part of the escape velocity is given already 1.110 to the power 4, right? Square root, this one just leave it like that, right? Okay, this first equation now. Okay, the second equation now, what is the escape velocity when the r add by 0.2? So now become 1.2 r, okay? 1.2 r. So now, so two situations, this is a first situation, given the escape velocity equal to this, right? So now this whole thing equal to this value. Now, new situation now, when the distance is 0.2 r from the Earth's surface, means the total distance now must is from the center, So it's 1 r plus 0.2 r, so become 1.2 r, the new distance, okay? So now, you take this value, substitute here, okay? Substitute here. So I take out 1.2, square root 1.2, take out, put here, I factorize. So leave this 2gm over r alone. Okay? Understand this mathematics? Because this value is equal to 1.110 to the power of 4, so you can substitute here, then you calculate, you get the answer 1 times 10 to the power of 4. Okay? So meaning that take out this 1.2 square root, put outside, leave this one alone, so that you can make this value to substitute here. Okay? So you get 1 over square root 1.2 times this value 1.110 power 4. So final answer is here. Okay? So far, can understand or not, you all? Huh? Can understand? Let's meet Chong. Can understand or not?
Can, sir. Can, sir.
Can, huh? Ashini, can you understand?
Can, sir.
Can, huh? Sima, can you understand? Sima, maybe lesson 3 you don't know lah. Yamai slowly you follow lah.
Yes, sir.
Okay, come. We move on. Next question will be even more difficult. My mouse, I click many times, very hard. Click it cannot come out. Okay, question number 5. What keeps an Earth satellite moving in its orbit? Okay, you must wondering, this satellite, right? When you launch a satellite into the sky, so this satellite will keep oscillate our Earth in a certain constant distant one, constant position. We keep oscillating. Must have something to do it, So the answer is because gravitational attraction between satellite and the Earth. Remember, the Earth is here. When you launch a satellite, go up. So now between the satellite and the Earth, there will be an attraction force between it already. We call it gravitational attraction force. And lesson 3, chapter 3, lesson 1, you go and see your notes, gravitational attraction force. So this, when any two objects like this, they will have gravitational pulling force one. Okay, so this gravitational pulling force will maintain the satellite. That satellite cannot escape now. It can only oscillate surrounding the Earth at that particular position. It's because gravitational attraction force between the satellite and the Earth. Remember or not? Okay, now mind. Let me ask you something now. When you have two objects like this, one is an Earth, one is a satellite. How to calculate the attraction force between the two objects? Do you remember or not? If you have the paper with you, you look at page 1, page 2, and then you can know already. What is the formula to find the gravitational attraction force between the two objects? For example, here, between the satellite and the Earth, what is the attraction force? How to calculate? What formula? Yeah, I know this. This student sure can answer one. Okay, Yu Tong, are you there? Yu Tong,
Yes, sir.
What formula? Can you tell me what is the formula to find the gravitational force between two objects?
F equal to G m1 m2 divided by R squared.
Yes, very good. Can you repeat that? You say it slowly, let other people listen. Okay, what is the formula? Say it again.
F equal to G m1 m2 divided by R squared.
Yes, correct. That is the formula. F equal G, big G, big G is the constant, gravitational constant. Okay, M1, M2. M1 refer to the mass of the Earth. M2 refer to the mass of the satellite here. Divided by R squared. R is the distance between the Earth and the satellite. Okay, so remember the formula, very important formula. Okay, next. Question number 6. If the Earth is uniform sphere, okay, uniform, then what the question asks? Radius is R. Which of the following is the graph of gravitational force on a body against a distance x from the center of the Earth? Okay, this question means it's like this, this is Earth, okay, center is here, so this is a distance radius, okay, R. My mouse cannot control tonight. Okay. Let me explain to you first. The gravitational pulling force actually the strongest is at the surface here. When you stand here, the gravity is very, very strong one. When you go to the center, here, actually, gravity becomes zero, Don't be surprised, no gravity one. Okay? Okay, I explain to you. From here, you go up here, right? The gravity is zero. Gravity pick up. When reach the surface already, the gravity become maximum. Maximum one. Okay, I repeat again. This is Earth. This is the center. At center point, gravity is zero. No gravity. Okay? Then slowly you move up, right? Then the gravity become bigger, and biggest at the surface. At the surface where you sit now, where you stand now, actually the gravity is a maximum. So it's here. So meaning that from here to here, the gravity starts from zero, increasing, Then maximum is here. Okay, what about outside? When you go outside, what happens when you go outside? Okay, common sense, right? The higher you go, the gravity higher or smaller? Hashini, the higher you go into the sky, the gravity becomes smaller or bigger? Hashini? So Michelle. The higher you, smaller, right? So remember, here to here getting bigger, but after the surface are getting smaller and smaller one. Okay, so the graph is like this. You see here? This is distance r, the radius, right? From here to here. Here is the surface of the Earth, so it's maximum. In the center, zero. Okay? Getting bigger, maximum at the surface of the Earth, the distance is radius, 1 radius. Then after that, go above the Earth already, the gravity drop. You see, drop a lot, drop so much, the gravity drop. So remember this graph, This graph is very important. It shows the gravity of the change in the gravity starting from the center of the Earth, then go into the sky. Understand? All right. Okay. Number 7. Periods of moons is 27 days. Okay, moon take 27 days to make one round on Earth. Okay, now the radius of moons. Okay, you see what the question say? The radius of the moon orbit is 3 times 10 to the power 8 meter. Okay, the moon radius. That means the distance, how far the distance of the moon from the center of Earth, the radius. The periods of geostationary satellite is 1 day. Okay, geostationary satellite means the satellite have the same speed with the Earth one. 1 day make one round one, isn't it? So what is the radius of geostationary satellite orbit? Okay, how to calculate this answer? Okay, now this question is in the information given to use period. Period one is 27 days, the other one is 1 day, right? Another one given is a radius orbit, the radius of the orbit, right? So meaning that you are given the values of T and R. So once again, I use a Kepler third law formula, okay? So the solution is, I think it's here, I put it here, it's here, okay? I explain here, you try to understand, because the question given, period and radius, period T squared over R cubed, this one put 1, first situation. Next, you put T squared over R cubed, but you put 2. 2 means another situation now. Okay, the first situation is 27 days given, right? The moons take 27 days, isn't it? Right? Period 27, no? And the radius of the moon given, right? 3.8 10 power 8 given in the question for this R. Okay, cube. Okay. Now another situation, the period is 1 day, just 1 day. So here is 1. So you are asked to find the new radius R2. Okay. In this chapter, you have to be very patient using a calculator. You do carefully. Okay. Okay. Now you use a calculator. This value cube multiply 1. 1 cube also 1 now. Okay. Then divide by 27 square. Okay. Do like this. Then this one times 1. So you get this one. So this one bring over to divide. This one bring up the R cube bring up. Okay. So use your calculator. You press everything here. Press here, right? Then you get the answer. Can someone tell me what is the answer? Someone use a calculator to calculate what is the answer? Can someone use a calculator to calculate what answer you get? What answer already? Nicole Chua, are you still there? Nicole?
A.
What
The
answer?
answer A.
Okay, hold on. I'm checking my mouse battery. Yeah. Yes, answer A lah, 4.2 10 to the power 7. Okay. All right, this one settled. Okay, question number 8. The acceleration due to gravity means the gravity acceleration on the surface of two planets are equal in magnitude if, okay, the gravitational accelerations are equal if, okay, you see the formula. First question we know already, the gravitational acceleration formula is G or A, right? Equal to Gm over R squared. Okay, based on this formula, from here, we can only see G memang is constant one. This is a constant gravitational constant. So M over R squared must be constant okay? If their M over R squared are same, means their gravitational acceleration also the same okay? The answer is C mass over radius squared, because you see the formula, mass over R squared. Okay, these two must be the same. Why not including the G? Why not including the G there? Joan Michelle, why the G not included? The big G.
Because it is a fixed constant.
Yes, correct. Joan Michelle, very good. Joan Michelle, where? Yeah, from which school one?
St. David.
I purposely ask you one. You think I don't know who are you? Know you lah. So yes, the big G is a constant. So no need put in one. It's a constant. Memang is already a constant. So as long as the mass over square of radius same, so the acceleration same. Okay, question number 9. Which of the following graphs show the correct relationship between the gravitational acceleration? Okay, see my mouse, not listen to my instruction tonight. Okay, with the distance x of a point from the center of Earth. Okay, in 1 minute time, I call your name, you tell me the answer now. Which graph show the relationship? Show the correct relationship between the gravitational acceleration with the distance x from the center of planet. Okay. Yeah, let me check the name, then I call you. I want to check also susah because my mouth not listen to me. Okay, now I saw already. Okay, Terry go. Are you there? Terry go. Terry, Terry go. Not there. Kelvin, so what answer, Kelvin?
D, sir.
Yes, the last one now. Oh? Last one. Okay, here. It's over here. Okay. A bit difficult to move. My mouse cannot move. Ayo, sorry lah. Okay, the answer is donkey lah, huh? Okay. Oh, the move also cannot. Okay, come. Yeah. Now this question. Okay. Sorry lah, give me some time. I go and change the mouse lah. Got another mouse. I go and change first. Okay, this one better. Okay. Okay, question 11 now. The structure question. Got one more objective, sorry. Question over 10. Yeah, come look at the question over 10. Read this question, a lot of calculation. No? A satellite P mass M orbit round the Earth in 24 hours. Okay. Another satellite Q mass 2M, double the mass. You know, just now the mass was M. Now it's double 2M. Okay. Also orbit around the Earth in 24 hours. Same, you know. Meaning that just now the satellite, the mass is 1M only. So the period to orbit the Earth is 24 hours. This one, another satellite, the mass double 2M, but the period to oscillate the Earth is also the same. So what is the ratio of the radius of Q, the second satellite, to the radius of the first satellite? Okay. Once again, in this question, given the particulars of period T, right, the time, and the mass, and the mass, you know, not given the radius. That means we cannot use a Kepler third law already, the T squared over R cubed. That formula cannot use here lah, because it's not given the radius. Now it's given the mass. Okay. Now we have to use another formula. Okay, you see here, like, take some time to understand it. Okay, we are using this formula. This formula, right? Okay, also involving period and radius Q, but also got the mass, you know. Okay. So this is another formula. T squared equal to 4 pi squared over Gm times R cubed. Okay, why I put here 1 and 2? Because the first one, the mass is M. Okay. The second one, the mass is 2M. You see the difference or not? Okay. And this one is 24 hours. This one also 24 hours. Can you do the calculation by yourself? I don't show here. Okay, I tell you what, here you put 24 hours, 24 square. Here also 24 square, because both also 24 hours, the period. So this is 24 square, here also 24 square. This one put 1m, this one put 2m. Because the masses are different. One is 1m, one is 2m. Okay, now they ask you to find the ratio of radius Q. Radius Q. Q means the second one, not this one, R2. This one, the ratio of R2 to R1. Okay, what you do, you take second equation divide by first equation. Use your mathematics skill. Can you do it now? Okay. Use second equation divide by the first equation. Okay, okay, try do it. Okay, second equation divide by the first equation. This T2 divided by T2, 24 divided by 24 square, so cancel become 1, no? 1, right? This one divided by this, you cancel everything, left the 2 only, 1 over 2. Okay, 1 over 2. 2 divided by 1. Okay, this one divided by this. Okay, so I get this, Use your mathematics skill. I don't want to write, you write yourself. 2 divided by 1. Okay, this equation divided by this equation. Left hand side you cancel, become 1. Okay, right hand side become R2 over R1, right? And here now you cancel everything, become 1 over 2 only. Okay, when this one divide this, right, you get 1 over 2. Okay, okay, do it now. Then you cross over, become 2 over 1, no? So the ratio of R2 to R1 is 2 to 1. Okay, so the answer is 2 to 1. Yeah. Yes, Kelvin, what question you want to ask?
Accidentally press, teacher. Accidentally press.
Or accidentally, I thought you want to ask question. Sorry that the paper, the space are very limited. Maybe you need to have extra paper to do the calculation. This formula also you have learned one, okay? Beside the Kepler third law formula, you also learn this formula. T square equal to 4 pi square over Gm over R cube. This question we have to use this because given the mass. Given mass, so we have to use this one, given mass. Exactly the same, two equations are here 1m, so here change to 2m. So this is 24 hours. 24 hours, so you divide. Second equation divide by first equation, you get this. So finally, you get the ratio R2 to R1 because it said Q to P, Q is R2, so it's 2 to 1. Okay? Yutong, do you understand? Nicole, do you understand?
Yes.
Yutong understand?
Understand.
Yeah, understand. All right. Now we go question 11, structure question. Okay. Can we move on? Okay. Now my mouse are easier to move already. Change it. I should change it earlier. Okay, question 11. Explain Newton's universal law of gravitation. This is Newton's universal law. So you must say two objects attract each other with a force proportional to the product of their masses and inversely proportional to the distance between them. Okay, you look at this formula. So two objects, this attraction force, Okay, from this formula you see, right, the attraction force is directly proportional to m1 times m2, product of the masses, right? Proportional to the product of the masses means m1 times m2. This constant only C1. And inversely proportional to the R. R means the distance between them. Okay, so the complete answer should be like this. Two objects attract each other with a force proportional to the product of their masses. You see here, product of their masses, and inversely proportional to the square of distance between the two objects. R square means the square of the distance between the two objects. Okay, got it or not? Hashini, got it? Got it answer? Hashini,
Yes, sir.
Hashini, can you read your answer again? Maybe some of them cannot get one. Okay, can you read your answer?
Two objects attract each other with a force proportional to the product of their masses and inversely proportional to the square of distance between the objects.
Between the two objects. Okay, thank you very much, Hashini. Must the square of the distance between the two objects, because this one involving two objects one. Okay. All right, thank you, Hashini. Okay, now P1. Show how the formula of gravitational. Okay, just use this one. Mg, this one is another formula, right? F equal to ma. Actually, we have original formula is here. No, okay, come, let me make it bigger first. The original is here. The gravitational formula, F equal to G m1 m2 over r squared. Right? Force F equal to ma from chapter 1, chapter 2, you all learn, right? Ma. Acceleration now you can change to G, gravity. Okay, gravity acceleration. So F replaced by mg. So now this m and m cancel. Finally, you get gravitational acceleration is gm over r squared. One m only. The other m cancel already. Okay, so that's how you get the formula. So now we already use the formula, correct? Not. So this is a formula for gravitational acceleration. Okay, number 2. Now calculation. Read the question. The distance of an object is 1.3 10 power 7 from the center of Earth. This is R. The distance means the R radius. Okay. Calculate the gravitational acceleration. Find the G law by the object. So use this formula only. Just use the formula. Okay. Now very simple. Take G value, the constant G value, is given here, I think, 6.67 10 power. This is negative. You cannot see a negative. It should be negative 11, sorry. Negative 11, okay? Negative 11, power negative 11. So you put here. Okay? Take G value, substitute. Mass, this one must choose the mass of the Earth. Okay? Don't choose the mass of the object. I know what is mass of the Earth. Okay? Divide by the distance r square 1.3 10 power 7 square. Okay, use calculator. Please calculate. See what is the answer. Wait for you. You must practice using a calculator. Okay, come. So what is the answer? Okay, let me see other people. Chai Pei Yin. Okay, Chai Pei Yin. What answer? Chai Pei Yin. Chai Pei Yin. What answer? Juling, what answer? Juling? Juling,
2.3.
What answer? Use calculator.
2.3.
2.3 times 2.3 only. Yes, correct.
3.6.
37. No, I got 2.37. No. You got 3.6. I got 2.7. I got 3.7. No. I don't know. You check. Maybe my calculator different from you all. 2.37 meter per second square. Okay. Right. Okay. Number 3. What is the variation of value of G if the distance between the center of Earth and the center of object increases? You increase the distance. Okay. What is the variation of value of G if the distance between the center of Earth and the center of the object increment further? When the distance further, the R become bigger, right? Okay, so the answer decreases. Decreases. Why? Because the distance increases means the R become bigger, right? R become bigger. The formula just now, the formula is here, this formula, right? Now you see, gravity actually inversely proportional to the square of the R, the distance. Okay, so now you increase the distance means this R become bigger, right? This value become bigger. When this value become bigger, you divide by a bigger value, your answer gravity become smaller. That's why the answer decreases because inversely proportional. You see, this one big, this one small. Okay, when the distance increases, so the gravitational acceleration decreases. Okay, so the answer decreases because gravitational actually inversely proportional to the square of the distance. Okay. All right, this one okay lah. 12. Read the question. Calculate the acceleration of Earth gravity at a distance of 350 kilometers from the Earth's surface. Now it's not on the surface, it's above the Earth, 350 kilometers away from the Earth's surface. Further already. And mass of the Earth given, radius of the Earth given. Okay, same formula now. Take G divided by the mass. This distance you have to add, this is a radius. Radius of the Earth. This one 6,400 kilometers change to meter at 30. Plus another distance because it's above the surface 350 kilometers. All change to meter This one is 6,400 the radius plus the distance above the Earth. So square everything. Okay. Use calculator, check. I get this answer. You check, see whether you get this or not. Each two, use a calculator to check. By right, when I finish discuss this set of paper with you all, your chapter 3 should be able to understand about 80%, 90% already one and all. Okay? Because many of you requested, asked me to repeat chapter 3. I said to repeat the whole thing cannot. Maybe I discuss some question with you. Okay? Yeah. Next question. Question 13. Okay, now. Okay, number 13. The mass of the Earth rocket. This one is a rocket. 2.5 10 to the power of kilogram. Move from the Earth to the moon. Okay, this rocket moving from the Earth to the moon. The mass of the Earth is, mass of the moon is, calculate the Earth's gravitational force. The Earth's gravitational force on the rocket when its distance from the Earth is 1 times 10 power 9. Okay? Understand the question? So nothing much. When they ask you to find gravitational force, the only formula you can use is this one. The first formula you learn in chapter 3. F equal to take G m1, m2 over distance squared, radius squared. Okay, now G value, substitute this one, the constant G value 6.67 10 power negative 11. Okay, G1, G2 because the question say the gravitational force between the rocket and the Earth, so you must take the mass of the Earth and the mass of the rocket. So this is mass of the Earth, isn't it? Mass of the Earth given, right? Now here given. Mass of the Earth not given, not here. And mass of the rocket 2.5 10 power 4. The mass of the moon, the one is deep one, no need use one. This one put here, mass of the moon just to confuse you, only make you confused. Understand? So you must really understand. This question is asking you to find the force between the rocket and the Earth. So you must take the mass of the Earth and the rocket only. This moon don't use, moon is deep one. So this M1 is the mass of the Earth. This one is the mass of the rocket. And this one is a distance. How to get 1 times 10 to the power 9? Because the question mentioned to you already. The distance here, 1 times 10 to the power 9. Okay, 9 squared. Okay, use a calculator. Calculate carefully. You will get this answer, 10.005. Okay. Yeah. Okay, last question before I stop now. Okay, the last one is Kepler's law 1, 2, 3. Okay, the 3 law you can copy lah. Kepler first law say what? Say the orbit of planets is an ellipse with the sun as the focus. Ellipse, E-L-L-I-P, as an ellipse. Or another word means the Kepler first law actually is something to do with the ellipse shape. Okay, the orbit of the planet is an ellipse with the sun as the focus. Okay. The second law, Kepler's second law. Second law is the line connect a planet to the sun cover equal area as in equal time as the planet move in the orbit. Read again to understand it. The line connect the planet to the sun. When it oscillate, right? So it will cover the area. It will cover equal area as equal time as the planet move in orbit. Okay. Second law, just memorize it. As long as it's the time to orbit same, right? It will cover the same area. Okay. Equal area with equal time. Okay. That is the meaning. And Kepler third law. Okay. We have used it so much already. The square of periods directly proportional to the cube of the radius of the orbit. T squared directly proportional to R cube. That's why you have the formula T squared over R cube, right? Kepler's third law, okay? Okay, now in 2 minutes time, I want you to memorize Kepler first law, Kepler second law, Kepler third law. Okay, later I ask you, okay, memorize it now. Memorize. You have to memorize Kepler's first law, second law, third law. The whole statement had to be memorized. Okay. Memorize it now. Memorize Kepler first law, Kepler's law 2, Kepler's law 3. Okay, there are 3 Kepler's law, 1, 2, 3. Yeah, time's up already. Come. Yeah. Okay, now when I call your name, you answer question. Don't hide yourself. Don't need to be worried. Okay. Carmen, are you there? Carmen,
Yes, sir.
okay, Carmen. Okay, can you tell me the Kepler's law 2? Second one. Kepler's law 2.
A line connect a planet to the sun covers equal areas as in equal time in equal time as the planets moves in.
Yes, correct. Okay. Thank you. You must remember it, Okay, next one is Chong Chao Yi. Are you there? Chong Chao Yi. Chong Chao Yi.
Yes.
Chong Chao Yi. Can you tell me the
Yes.
Kepler's law 1?
The orbit of planets is an ellipse with sun as a focus.
Yes. Okay. Very simple. Thank you very much. And last, let me call this Kian Leong. Kian Leong, are you there?
Yes,
Kian Leong, can you tell me the Kepler's law 3?
the square of period of a planet is directly proportional to the cube of the radius of the orbit.
Yes, okay. Then the formula, can you tell me or not? Then good, your answer is good. You know the Kepler third law formula?
T square over r cube equals T square over r cube.
Yes, correct. Then you put 1 on the left, 2 on the right. Okay. I think tonight I'm going to stop here. Okay. There are many things are not smooth tonight because my mouse problem. Then later on only I change my mouse. Okay. Okay. Wednesday I see you again. I know quite tension for you all. 1 week I want to see me 2 times. Okay. Next week you can rest. Next week 1 time only. Okay. This week you struggle a little bit more. Okay. Be more patient a bit. Okay. Wednesday night we continue discuss. By the way, the paper you all need to print it out, print out and then you try it first, try to answer the question. Actually, the structure question behind, not so difficult one, Okay, not so difficult one. Okay, you try to answer, refer to the notes, okay? You have the notes with you, right? Before this, you have 1 set of notes, 1 set of questions, right? You're referring to the notes, referring to the question you have done before, okay? And then try to answer it first. So on Wednesday, we try to finish up all. Okay? So take good care of yourself. Before this, anyone want to ask any question? Anything you want to ask or not? Anyone got anything to ask? Tan Choming, anything to ask? Wendy, anything to ask or not? Menti okay, if no question to ask, okay, take good care of yourself, continue to study, must study at least until 2 hours, 3 hours a day, must study Form 4 already. Yeah, no more small kid, not small kid, every day playing only, you have to study at home, okay. So once again, thank you very much, okay, bye-bye.
Thank you, sir.
Okay,
Thank you,
bye-bye,
sir.
bye-bye.
Thank you, sir.
Thank you, sir.
Okay, bye-bye,
Yes. Thank you, sir.
bye-bye,
Thank you, sir.
Thank you, sir.
bye,
Thank you, sir.
Thank you, sir.
bye.
Thank you, sir.
Okay, bye-bye, bye-bye.
Bye-bye.
Thank you, sir.
Okay, bye-bye.
Thank you, sir.
Okay, bye-bye.